Hi guys, welcome to this video where I'm going through this question from May-June 2022, and it's one of the tricky questions on tangents and normals involving differentiation at AS level, right? And it reads: curves with equations y equals 2x to the half plus 1 and y equals half x squared minus x plus 1 intersect at A, which is at 0, 1, and B, which is at 4, 5, as shown in the diagram. A is over here and B is right here. The acute angle between the two tangents at B, which is this one, is denoted by alpha degrees, and the scales on the x's are the same. Then it says find alpha, right, for 5 marks. So one of the things that I encourage my students to do when solving these questions that have 5 marks, 7 marks, or 9 marks is to try and map out your working first, what you want to do first. Know what you want to do and go ahead and do it. Don't just start writing without actually assuring yourself the way you want to use to get to the answer, right? So try and map your work out, map your method out, know what you want to do and go for it, right? So for this question, we see that we have two lines, right? We have this line, which is a tangent to this curve, right? And we also have this, which is a tangent to this curve. And so what I'm going to try and do is to find the gradient of this tangent, this one, at this point where x equals to 4, right? And for me to be able to do that, I'm going to use this, right? Since it's a tangent, we know the gradient is the same at that x value, which is 4. And I'm going to do the same for this other tangent, right? Then after that, I'm going to use the understanding that if I have a slanting line and a horizontal line like this, to get this angle, and if I have the gradient of the slanting line, if I say tan inverse of the gradient, I get the angle, right? And for us to get this, we're going to do it this way. We are going to say, if we have a horizontal line here, right, and the gradient of this, which we can call m1, we can say tan inverse of m1 to get this angle, right, the angle between the slanting line and the horizontal line, right? Then we get that. Then after that, we do the same with this right here. So if we find the gradient, which we can call m2, then we say tan inverse of m2, right? We get this angle between that slanting line and the horizontal line, right? So after that, we just say this minus that, so it's 2 minus 1, then we get this angle right here, right? That's how we're going to try and work this out, right? And for us to get the gradient of this first one, that's dy dx. We're differentiating dy dx, take down the power, then 2x, we subtract 1 from the power, that will give us minus a half, right? And this will come down to be x to the power minus a half, right? And at x equal to 4, so when x is 4, dy dx is equal to, that's like 1 over x to the half, so 1 over 4 to the half. We know 1 over square root of 4, that's 1 over 2. So that is the gradient of the tangent for this curve at x equals 4, right, which is our m1. So m1 is half, right, and tan inverse of m1 will be tan inverse of half, right, and that will give us tan 1 over 2, that will give us 26.6 degrees, right, meaning this angle in blue here is 26.6, right. Now to find dy dx for this, simply saying dy dx is equal to, taking these two down, to multiply by half we get 1, then we subtract 1 from the power of x, so that's x minus 1, like that, and substituting 4 for x, like when x equal to 4, we know dy dx will equal to 4 minus 1, which is 3, right. And for us to get, since our m2 is 3, right, we know the gradient of the tangent is the same as the gradient of the curve at this point, right, where the tangent is touching the curve. So that would be 3 there. Our tan inverse of m2 which is 3 will give us tan inverse of 71.6 degrees, right. Then for us to get alpha there, alpha is this, which is 71.6, minus this, which is 26.6. 71.6 minus 26.6, then we get 45 degrees, right, rounding it to 1 decimal place, not 1 decimal place, to the nearest degree, yes, to the nearest degree, because the answer we get there is 44.96. So rounding it, we get 45 degrees. I hope that was clear enough.